Okay, hi, good afternoon everybody. Welcome to another episode of Math with the Thinker's Cap. Okay, my name is Mr. Tam. Okay, in today's lesson, we're going to discuss, an expansion, right, that is usually taught in Sec 3A Math, which is known as the binomial expansion, right? Okay, the importance of learning the binomial expansion, lies in the expansion being able to handle the powers, right, of high magnitude, meaning it could be up to magnitude of 8 or 9 or even higher, right, where my brute expansion using the normal opening of brackets will prove to be too tedious, right, to find out the full expansion. And therefore, the use of the binomial expansion will allow us to pick any particular term inside the expansion without having to do a full expansion. Right, let's recap how the binomial expansion looks like, right? Okay, in this case, I have the a plus b bracket to the power of n, right? Meaning a plus b multiplied by itself by n times, right? Okay, in this case, my n, is an integer, positive integer, right? Okay, that is more than 2 and above, right? It must be an integer, right? Okay, and that is within the scope of what we learned in A math. Okay, so the expansion will look like this. For the first term, it will be nc0 a to the power n b to the power 0, right? The second term will be nc1 a to the power n minus 1 b to the power 1. Third term, nc2 a to the power n minus 2 b to the power 2, right? And in the middle, where I have a general term, the position can be any position, right? But the general term, right, can be written as what? ncr a to the power n minus r and b to the power r. If you notice the pattern, right, where the series, is being written, right, when this is 0, this is the first term. If this is 1, this is the second term. If this is 2, this is the third term, right? And therefore, right, there's a relationship of +1, right, based on this number here. And therefore, if this is r, this must be the r plus 1 term. And therefore, we call it r plus 1 term formula. All right. The other observation that you should make is at any point when you add up the power, right, of a and b, they should add up to n, right? So take for instance the first term, n plus 0, I get n. N minus 1 plus 1, I get n as well, right? So that is itself is an important check, right, to make sure that you have written your series correctly, right, before you proceed, to work on the expansion. Let's see how we can make use of the r plus 1 term formula to find out a particular term in expansion without having to do our full expansion. Right, so take a look at this example here, right, where I have x squared plus 1 over x to the power of 12, right, and I wanted to find out what is the term that is independent of x, meaning I want to find out the constant. In this case, I have power of 12, meaning if I'm going to do a full expansion, I'm going to have 12 plus 1 terms altogether, meaning I've got 13 terms, right, before I can find out which is the term independent of x. So I'm going to make use of the r plus 1 term formula to help me find out where exactly is this term. So my r plus 1 term formula gives me ncr, my n is 12, cr, r is unknown, which I'll be finding out later, right? I've got x squared, my a is x squared, 12 minus r, and my b is 1 over x to the power of r. Alright? So in this case, I'm going to combine the terms containing base x and try to equate the power of x, right, to the power of x that I desire to find out. Right? So in this case, I'm going to make use of the laws of indices, right? So I have 12cr x. The power here I'm going to multiply, right, based on laws of indices. 24 minus 2r. I've got x to the power minus 1 to the power r, which is minus r, right? And by combining them further, I've got 24 minus 3r. X to the power 24 minus 3r. Since I'm looking for a term independent of x, right, this term has got the power 0, constant. Alright, x to the power of 0 is exactly 1. Alright, so I'm going to find out what exactly is this term here, right? So I'm going to find out x 24 minus 3r. I'm going to equate it to x to the power of 0. And therefore, I can also equate the power, right? 24 minus 3r equals to 0, right? Which gives me r equals to 8. Okay, notice my r must be a positive number and must be an integer. So the moment you find out that your r is not an integer, not a positive number, you've got to go back and check out and see where you have made your mistake. Alright, so in this case we found r is equals to 8, right? And therefore now I'm going to substitute back into my expression here, right, to find out the term that is independent of x, right? So my 8 plus 1 term, right, will be equals to 12c8, right? The x will confirm the x to the power of 0 because since I've already equated to 0, right? Okay, and therefore this will be x to the power of 0, right? So you can leave it out if you decide, okay, not to write it down, right? Okay, so my 12c8, right? Okay, you can press the calculator, you could get 495, right? And this is the term that we're looking for in the independent of x, a constant term, right? And where's the position of this term? Okay, based on the r equals to 8, okay, this is actually my 9th term, okay, in this expansion. Alright, so you can see, without having to do a full expansion of getting the 13 terms before I can find out my constant, I'm now able to make use of the r plus 1 term formula to pick out the term that I'm interested in and to find out only that term. Right? I hope that you have found this lesson useful, right, in helping you to understand how to apply the r plus 1 term formula, okay, in the case of binomial expansion. Okay, if you like our lesson and like to find out more about lesson, click on our link below, okay, to find out more about classes, and I hope to see you on the other side. Thank you.